How's it going? So in this video I'm going to do an analysis of this 3D printed part I received. It's a burr carrier that I received from Rio Grande. You can see it's a circular part. It's got this really nice snappy detent mechanism, and that's the main reason I want to make this video, is I want to analyze how this part works and what gives it that nice snappy feel. If you don't know what a burr carrier is, on your jeweler's micromotor or any other kind of device that takes a 3/32 shaft tool, you basically can just have these like little tools that run in there. This is a circular burr. I'm not sure if that's going to focus correctly. That's like a little burr you would use for jewelry making. And this part basically just has a whole bunch of those in it. So they slot into these little holes there. I don't know if you can see that. And then they get hidden away in this nice snappy mechanism. So I received this part and I was like, that's kind of cool. This isn't something I'm probably going to like throw away immediately because it's sort of interesting. So I thought I'd tear it apart and figure out how it was printed, how it was designed, why it was designed the way it was designed. Maybe make a little bit of commentary on some of the pros and cons I think exist in this design, and then actually try and design my own version of it, because I was really interested in how to incorporate this mechanism, this like snap mechanism. To me, that mechanism is clearly not something that's coming from purely being 3D printed. There's some other component in here, I think, that's giving us that nice snap fit. So that's what this video is going to be about. I'm going to pull this thing apart and figure out how it works. All right, so let's start taking a look at this thing. I guess the first thing I should do is try and find my burr that I put in there. There it is. Just remove it pretty easily. Nice. Probably the first part of this design I want to call out is the maker. So you can see that's printed on the inside of the upper burr carrier component here. That's Nashif Designs. I believe that Nashif sells these parts commercially. So although we're going to recreate this part in Onshape, we're actually not going to, try and replicate this exactly and provide an STL and all that kind of stuff, because this is some guy's livelihood. So we're not going to do that. We're instead just going to use this as a learning exercise to try and figure out what we can learn about it, how it was made, what kind of mechanism is in there. I'm always interested in 3D printed mechanisms and other kind of like mechanisms like snap fit components that are on here, which we see on this part. So that's the primary exercise we're going to go through here, and I'd encourage anyone who's interested in a part like this, who's like, oh wow, I would really like to mass produce a part or use this exact design or whatever, go hit up Nashif. He's got a website, I'll put it in the description. He seems like a really talented jeweler and 3D parts maker, and so I really want to make sure we emphasize that it's this guy. This guy made this. So let's not forget that. Show him some love if you can. All right, let's talk about the part. So I think first thing I noticed was like, wow, I don't really want to throw this out, right? Like normally your burrs arrive in something like this, which doesn't exactly spark joy. It's kind of injection molded thing. Your burrs come in here all standing up like that, and the first thing I think about when I think about this is like, great, I'm not gonna keep this thing. It doesn't sort of match with any of the other designs I've got laying around. It's like inconvenient, it's tall, it's bulky, it's just trash basically, which is a shame. So unlike this, I got this and my first thought was like, ooh, what is this? Like, I want to play with it and fiddle around with it. Here's another kind of burr carrier that you get. It's just a box with a lid. The lid doesn't particularly stay on there very well. So we're obviously not going to keep these, but we might keep this. This is actually pretty cool. So I think it's interesting because it invites interaction, right? And I think part of that is the circular design. I think part of it is the two-toned plastic that was used in here. I believe Nashif uses PLA for these parts for sustainability reasons, according to his website. So that's obviously great. This isn't. At first, I thought this might have been an ABS printed part, but my understanding is this is PLA. I could stick a piece of it in acetone or something and see if it like melts, but I'm just going to assume this is PLA. I think the other interesting part of this design is that dimension-wise, it's actually feels like it's been deliberately designed to fit in your hand, right? I don't think it's a coincidence that my hand fits kind of like more or less perfectly over this. And I think if you go into a lot of like historical design, you'll find parts that are actually designed with the dimensions of human body parts in mind, whether it's like, you know, length of the sort of forearm or length of fingers or whatever. This could have been smaller, right? This could have been much smaller, but instead it's sort of designed basically, I think, with a human hand span in mind, which I think is cool. That's really interesting. If it's true, it feels like it's true. I'll just run with that. So that's another element. The downside is it's pretty large. It's going to take up a lot of space on my bench. In fact, it's not going to take up any space on my bench. I'm just making this video about it. I don't actually use this for storing burrs. I have everything in a Gridfinity setup here. I've got a whole drawer full of these, and ignoring these other, I don't know what you call them. These like, there's a word for them. Basically, things you can attach other things to. They're 330-second burr sort of carriers. You can put like circular cutting discs and stuff on these guys. So ignoring those, everything else that's on here is the full contents, excluding this little guy, which I guess I should put in there before I forget it. This was the full contents of all of these, of this entire burr carrier. Like, there's a sizable size difference there. So it's not the most space efficient or economical in terms of space. So that's a downside. However, I think there's another design element to this, which involves this ring on the bottom. At first, I couldn't figure out why did they put another. This is a whole other part that's on the bottom here, and it's kind of, I don't know if you can see it. It's kind of torn up because I had to hack it to get it off. It's super glued on there, so. I was trying to think like what is the purpose of this thing, and I thought about it for a while and I was like, oh, it's for stacking. So I don't have a second one of these, so if I just pop this off, I feel like this could have been snap fit designed to snap fit on there instead of requiring glue, because it was definitely glued on there. Like, that's going to be an extra post-processing step. Someone's going to have to, like, you know, get out some glue and do that, and it's sort of like is designed to, it's a friction fit. It goes in there. If I just like try and get that back on, it does actually kind of snap in there, kind of, but probably not well enough for the intended use case. I imagine that just with people picking it up and like pulling on it, they probably couldn't get it to snap fit on there well enough with this design, which is fine. Like, glue is an option. It's just interesting from a design perspective to think about, like, you know, designing this thing, it comes in, it's going to have 3 parts. These are all 3 separate 3D printed parts, and you sort of like want to minimize the post-processing if you can, right? You want to minimize use of supports where possible. And this is obviously a fiddly sort of post-processing step to have to glue this thing. But anyway, the reason why this thing exists, I think, is because of the ability to stack. So if I flip that over and just like pop it on there, well, now I'm thinking about which way that was. I think it might have been that way. Yeah, see that? It sort of like goes click, it sort of clicks in there. I think it's designed to stack. And that could be cool if you had more of these, like you could stack them on top of one another. And then this whole central area, you could, I don't know, put other things in there, whatever you want. So that could help bench efficiency a little bit, so your jeweler's bench isn't getting too clogged up by this giant part. But that's sort of where the downsides end. I think, you know, everything else I want to talk about with this part is actually really cool. So yeah, probably the first thing we want to talk about is what is this mechanism in there? Because, like, as I mentioned, I don't think it's 3D printed. I think there's an extra component in there. There's probably some metal part that's in there. And so to figure that out, we're going to have to pull this apart. So how is this thing joined together in the first place? Because it's not coming apart even with a decent amount of force. It's locked in there, and the mechanism for doing that is pretty obviously these guys, these snap fit connectors that are sort of like holding onto this rim on the inside of the part here. So to get this thing apart, we're going to have to just lever it apart a little bit without breaking it. And let's see if I just jam a few of these guys in here. I think I should be able to pull that apart. It's a miracle I haven't broken this, because I've pulled it apart quite a few times now. So now that we've got this apart, one thing to talk about is these clips, these retaining clips that are these snap fit things that are actually holding the top of the burr carrier to the base. The 3D printing orientation of this is pretty obviously like this. It would have been sitting on the base plate and then printed layer by layer up. You're not going to print it like that, obviously. Well, maybe not obviously, but if you print it on the base like this, you can build everything up with no supports, which is, I think, obviously a design criteria that you would want to meet here. And you can even tell if you, I don't know if I can get the camera to sort of like zoom. Oh yeah, we'll focus on that. It might not come through on the video, but the texture of this bottom surface here it's textured. It was printed on a textured build plate of some kind. There's a faint texture there, and there's a little bit of a chamfer on the edge here, and then it's printed up from there. So the problem with these retaining clips, printing it in that orientation, is the layer lines are cutting across the part this way, and so if you put like a ton of force on this thing, if I push that really hard with my thumb, it would break this connector off. And that's usually a concern if you've got a part that's going to go through multiple cycles of being pushed like that. But I don't actually think it's a problem with this part, because it's designed to be like put together once, and then after that the loads that are on these snap fit connectors are just going to be there to keep the thing from pulling apart like that. So ordinarily you'd be a bit worried about printing in that orientation. I don't think it matters in this case, and plus there's like 6 of these connectors and they're fairly beefy. They're fairly thick. I think they're about like 2 mils thick or something like that. So I actually don't think that's a problem. I think it's been well designed in that case, and it certainly survived me, manhandling it and pulling it apart a couple of times. It tends to come apart fairly violently, as you saw. So the bottom piece, not a ton to talk about here. It's a similar kind of deal. Like there's a textured pattern on the bottom. That looks like it's coming up on camera a little bit better. Textured pattern there, so it's obviously printed in this orientation. There's this boss that's sticking up here, and lo and behold, that's our little secret part. This is a spring-loaded ball plunger, this part here, and don't know if I can, you won't really be able to see it on camera, I think, because it's so small, but basically it's just a ball in a little carrier with a spring behind it, and it pushes down. You can push this down. It's actually quite stiff. I think this is probably like maybe a 5 or 10 Newton. You can buy these in different stiffnesses. In fact, I've got a whole bunch of them here. This project, I bought a whole bunch. So got some tongs here. Pull one of these guys out. That's basically it. So it's like a tiny little ball bearing, basically, that just sits in this housing with a spring behind it. And you can buy these on Amazon, which is where I got these ones. I also got a bunch from McMaster as well, which are a lot more expensive through McMaster. Go figure. I think these guys might have come from McMaster. But you can basically buy these in all sorts of different sizes, all sorts of different diameters, all sorts of different ball sizes, and spring weights. So I bought a whole selection of these. I think like I don't know what strength this one is. I think feels like it's more than 5 newtons. I think it's one of the stiffer ones, and you can kind of tell from the big ka-chunk when this gets spun around. It's got a very positive action. So where does this ball sit? There are basically all these like little indexing holes all around the circumference of this part where it goes click and just sort of like captures the next index there, which is neat. It's a little bit stiff to rotate it. In fact, it's so stiff that you've got so much torque on this when you're spinning it that sometimes it kind of like overshoots the index and doesn't like kind of cleanly hit that detent. That's another like minor design consideration, I would say. What else is there to say about this part? We know it's printed in PLA. It's really stiff and sturdy. I don't know. I don't want to completely dissect it to find out what kind of infill pattern or whatever they used, but I did notice, might be a little bit hard to capture on camera, there are these little dimples all throughout here which are part of the seam. So I think there was a randomized seam used on the outside for the cosmetic side, so you don't see any nasty kind of seam. Whereas on the inside, there is a seam. There's a seam over there that runs up and down. And I'm thinking, I don't know what slicer did that. I'm not sure if my slicer, usually Bamboo or Orca, I don't know if you can do a straight seam on one side and a randomized seam on the outer perimeter of the part. I might have to go into the slicer and see if I can do that. But anyway, the net result is that it's a nice clean outside. Like, it's still obviously 3D printed, but it feels like high quality part from my perspective. So yeah, I think what else is there to talk about? There's like little windows in here so you can see the burrs. There's all the text on the outside with little sort of detents there, or indentations to sort of indicate where things are. So I think probably what I'm going to do now is show you a example part that I created based on this using the same mechanism, and then we'll look at it in Onshape and figure out how I did that. So this is the part that I printed and designed, and it's basically the same kind of idea. It's 2 circular pieces that have a snap fit mechanism. You can see those little retaining clips in there that snap over, and you can twist it. You get a nice snap for each detent. If we pull it apart, this one comes apart a lot easier than the other guy. You can see the same. There is our little mechanism in there, the little ball detent. Sorry, what is it called? Spring-loaded ball plunger. That's what that is. Sitting on a boss, like with the other part, and the indexing holes on there, right around the perimeter. Snaps together. So I think there's a bunch of different places you could use this kind of mechanism. And funny, I should mention other mechanisms because I have one more of Nashif's parts here. Also, I think I ordered this from Pepe Tools. This second part. This is the second part. This is a saw blade holder for a jeweler's saw. And wouldn't you know it, but if you spin the top, another one of those mechanisms. Who would have thought? And if I wedge this open quickly, let's see here if I can just do this non-destructively. Pop this off without saw blades going everywhere, because I'd never reorganize these again. There we go. Look at that. That's another little spring-loaded ball plunger sitting on the top. This time it's indexed on those cutouts on the bottom of this, and another nice snap fit piece here, a giant honking clip that's split into 4. And again, like, it's an important characteristic of these snap fit connectors that they are split like this so that they can flex if this was like one whole part, you could probably jam it in there, but it wouldn't go in as easily as this one does, like that. Same with this, if this was just one circumference around here without these cutouts in there, then these components wouldn't be able to flex independently of one another, and it would probably snap together, probably, but it'd be ugly. And so that's why you need these degrees of freedom in here for these parts to be able to mate in with one another. So yeah, let's go into Onshape and talk about how this was designed, and I hope that some people are able to think about these spring-loaded ball plungers and maybe incorporate them in some of their own designs. All right, here's the part in Onshape. Let's take a look at it. So you can see I've modeled the two burr carriers, the upper and lower piece, and let's throw in a section view. Let's see here, we've modeled everything with clearances. We've got those indexes for the ball plunger to fall into. We've got our retaining clips modeled out here, so let's take a look at how this was modeled. If we go all the way back in the feature tree to the main profile, anytime I start with a part that's circular like this, I'm always thinking about a revolve. So that's how I modeled this piece. You can see the profile here of the upper part of the burr carrier just traced out. I just took all these measurements with a set of calipers, and I didn't try and be too precise. As I said, I wasn't trying to model the part perfectly accurately, but just sort of create something that has the same mechanism. So I've got here the just two circular kind of bosses that stand out to form the part of that snap fit connector. So we just revolve both of those to create the geometry that we want here, and then we have to go through and add clearances and add all the other features. So the first part that gets added after that is this cutout profile here, which is going to be projected backwards, I think. So if oh no, it goes through there. So I basically just created that profile to sort of like YOLO the dimensions a little bit, because it doesn't have to be super accurate here, and then did a wrap to remove that geometry to create that. And you can see under here we basically just need to pattern that around, and then we get our retaining clips to keep these two parts together. Next thing I added was a clearance fit for this rail up here that the top part of the burr carrier is going to travel on. When we print this, these tolerances here are going to, it's never perfect with 3D printing. You always get like a little bit of slop in the part. It's never sort of like perfectly dimensionally accurate, so there's a bit of trial and error involved. So what I did was I just created a clearance fit that just brought those two sides in a little bit, I think by 0.1 of a mil, just to create some clearance there. And then what you end up seeing here is when you create two circular parts like this, you kind of don't want them to match together perfectly. Again, it will create like a little bit more friction, but it'll also be like a little bit uneven. You'll get sort of some sections where you can sort of see a little bit of a gap, and other sections where they're flush. So I think I saw this on a teaching tech video a while ago, the idea of a shadow line. So what you do is basically just create a little gap between these, just moving the faces up, just to create like a little bit of a forced gap between these two parts, and that's just going to make it look a little bit better. It's not going to be sort of uneven around the circumference of the part. So that's just a little cosmetic trick basically to make a slightly better looking part. So the next thing we need to do is create a position for the plunger, where the ball plunger is going to go. So I basically sketched out a line here and put a plane on top of that and a profile for where the plunger is going to go. I sort of measured the dimensions of the plunger. And then I needed to create the boss for the bottom here. So I used a sketch on this plane here to basically create a sort of symmetric arc going out between these 2 points here on the circumference, and then just extruded that out. So we've got our little boss standing up there. And then while I was in here, I guess technically you're supposed to do this at the very end, but I just threw the chamfer on the top and bottom of the part there. Again, just like a cosmetic appearance. Feels a bit better in the hand. You're not gripping a part that has a sharp edge. I then decided to import a part from McMaster that was about the same dimensions. I went into their website and got a CAD for that and imported it. So just inserted that part. If I hide the top and bottom here, you can see that that's the part. And one interesting thing about this part is that it actually included a spring on the inside. These McMaster CAD parts are very accurate. They've got all the components in them. But I'm going to use this ball plunger as basically a piece of geometry to subtract a hole for me to press my own ball plunger in there. So I actually need to delete that spring. I don't want that spring there. And then when it comes to the body here, again, because we're going to do a Boolean subtraction, the fact that this is an empty shell, if I remove the ball, that's going to be a problem for us. So what you can actually do is just move the face, this inside face, all the way in to close that up. And that's now a watertight solid piece of geometry we can use for a subtraction. We do have one other problem, which is that where this is positioned, it's actually inside this part here, because I actually want it to push into the part a little bit. I don't want it sticking out proud, otherwise it's going to catch when the top rotates around. So I actually have to push that part in, and when I do a subtraction, it's going to be more or less totally enclosed. You can see it's just poking out here a little bit. So what I needed to do was basically just subtract from this face outwards, just to create like a little reveal for that, so it actually can poke through. So I created that clearance there just using the front face of the ball plunger just to subtract that, and then I can subtract the rest of the plunger, and then we're left with our little modeled hole there for the ball plunger to sit in. I could probably have gotten away with just doing a much more simple subtraction there, but I kind of wanted to work with the McMaster CAD just because I think it's pretty cool that you can get those CAD pieces and use them in your design. Next thing we need to do is actually stick on that ball there, because I just subtracted the housing of the ball plunger, and I'm going to use this ball to create the indexed dents in the top part. So if I hide the bottom, you can see that ball is actually protruding into the surface on the top there, so I can actually use that as a subtraction and create those indexed points all around the top part of the burr carrier there. And then to get the text, don't really need the text. This was just like an interesting exercise for me. I made a feature script to do this. Basically turn that on and I get a nice text pattern around the outside. This ended up being, maybe you could do this with manually, just with wraps, but I wanted to be able to programmatically sort of control this, so I put together this feature script that I won't go into here. It's fairly straightforward. It's probably pretty ugly, but I just enumerate over a bunch of strings here and create those strings and then position them around the outside and do all the, the wraps and the thickenings and the Boolean operations and whatnot to create this. And that was basically just a nice way of getting all of that controlled and wrapped around the outside. There might even be some custom feature script that does this that I didn't find when I was researching this. It was just an exercise I went through. So then we need the little tick marks that are aligned with this text, and so I created a plane for that somewhere around the circumference, and then sketched out a little profile for it here, and then just extruded and patterned that around the outside, and that gets us the completed part. So it was really as simple as that. There wasn't really too much to it. It didn't take too much iteration. Actually, most of the iteration I had to do was based on the ball plunger itself. The ones I got from McMaster, the spring was too soft in them, and I ended up having not a very positive clicking motion as I spun this around. So, I was able to just get some different ones on Amazon and use those instead. But yeah, that's it. That's our part. So hope you enjoyed this short walkthrough. You can find this CAD if you search for it. Search for burr assortment in Onshape. It's a public document. If you want to take a look and learn a bit more about it, or maybe look at the feature script or whatever. So yeah, hope you enjoyed.